Hello, friends. In the very first lecture of the course, Combinatorial Mathematics, we'll study certain basic facts regarding the sets which are essential for the combinatorial mathematics. So, outline is here that we'll study definition, cardinality, power set, and cardinality of a power set, and what is the proof. The basic definition of the set is this well defined collection of distinct objects, members, or elements is called a set. For example, you can see here if we take the vowels from the English alphabet, then A, E, I, O, U. If we list these elements in a collection, because this there is some property that these are the vowels from the English alphabet. Therefore, we are putting these in one collection. So that is why this is a set. Second one is the set of the primary colors. So there are various representation for the sets. So you can see in the supplementary material here or the core material associated with this video lecture. Then we come to the cardinality of set. Suppose a set has n elements, a finite set, n is greater than or equal to 0. Then this absolute S denotes the number of elements in S. So this is represented here like this, that number of element in S is n. Then you can see the example here how we can do this, that suppose this is set A and there are four elements 2, 6, 9, 7. Then the number of element in A is 4, and in a single set we'll have only one element. For example, here A, this is the cardinality of this set is one singleton set. Now just come to the power set. For any set X, the power set of X written like this, it is a representation, and it is a collection of all subsets of X. For example, here you can see that this set X has A, B, C, three elements. Then the power set consists all the possible subsets of this set X. So here you can see that there are eight elements in this power set: one, two, three, four, five, six, seven, eight. Now, it is simple that these are lesser number of elements. But if number of element is more, suppose a set is having n number of element, then what is the number of element in the power set? Then answer is 2 raised to power n. Everybody know, and it is school level problem here. But how it comes out to be like this? How this set has 2 raised to power n elements? So for this, we need to look for some method of the enumeration that computes the number of elements in a power set of n elements. So for that we required some combinatorial formulae. So in the heads in your secondary classes, you we are taught about the permutations and combinations. So this is a permutation formula and this is the combination formula. You can look at it. Then with the help of these, uh, the number of elements in a power set can be calculated. So one more formula is required here, and you can go through it how that comes out to be uh, like this. You can consult the supplementary material, and we can discuss in the class further. So this is the resource I have considered from this. Thank you.